All right, example 3 of the ideal gas law. Go ahead and hit pause to give yourself some time to record the question into your journal. We're going to start this problem in the same manner as all the other ones by listing our variables off to the side and inserting the values that we do know. I always know R, that's 0.0821 liters times atmosphere over moles times Kelvin. Well, what do we know about this specific gas? Well, we know that there's 5.4 grams present and it has an identity of carbon dioxide. That's how much carbon dioxide we're going to put into this container. So I'm going to put 5.4 grams of CO2. The size of the container is 20 liters, so our volume is 20 liters. And the temperature is 305 Kelvin. What is the pressure of the gas? So we don't know what the pressure is. We are solving for pressure. Okay. Now, let's check our units. For pressure, we have to be in atmospheres. So even though the question didn't mention atmospheres, because atmospheres is what our R is measured in, I know that in the end, when I get my answer for pressure, the unit is going to be atmospheres. Volume needs to be in liters. Check. Yes, it is. N needs to be in moles. Uh-oh. Problem here. Okay. Our amount of gas right now is in grams. So we're going to need to convert this into moles. So we're going to come back and do that. And then final check for our temperature. Temperature needs to be in Kelvin, which it is. Okay, great. All right, now back to those moles. I need to convert those 5.4 grams of CO2 into moles. And we're going to use dimensional analysis to do that. 1 mole of CO2 is equal to its molar mass from the periodic table. So pull up your periodic table. Carbon dioxide is 1 carbon and 2 oxygens. So you want to add together a carbon, which has a mass of 12.01, and 2 oxygens, each one has a mass of 16. So that's going to give me a mass of 44.01 grams of CO2. Okay, we know that 1 mole of CO2 contains 44.01 grams of CO2. If it helps you also, you can put that 1 underneath the 5.4 grams. And now we know that our units are going to cancel, grams and grams, and we are left with moles on that top row. And now we just do the math. 5.4 divided by 44.01 in the calculator is going to give me 0.1227 moles of CO2. And because this is not a final answer, I don't want to round for sig figs just yet. A good rule of thumb is keep 4 sig figs in these intermediate answers, and then you'll avoid any rounding mistakes. So we're going to insert this in for our N. Okay, so now our units are great. We do have our amount of gas in moles. Now that my units are good to go, now I can take the ideal gas equation, PIV-NERT, and rearrange it and solve for our unknown, which is pressure. So we're going to divide both sides by volume. And so pressure is equal to nRT divided by V. Now it becomes a simple plug and chug. We plug in the variables that we have listed off to the side, and now we calculate the pressure. I'm going to calculate a pressure of 0.1536, and don't forget that we already said that our unit was going to be ATM. And our final thing is to round for sig figs. We want 3 sig figs in our answer, so pressure is going to round to, we want 2 sig figs in our answers because we have 5.4 grams of CO2, which is just 2 sig figs. So this rounds to 0.15 ATM as our final answer.